All right, welcome back. We are GAME3001 in the winter 2021 semester, and that's at George Brown, and it's week 13, part 2 of our broadcast. And right now we're going to be doing our labs. So lab 10 is, here are the goals for lab 10. I'm going to improve our line of sight check. I want to fix that line of sight bug that's been plaguing me, that's for sure. I want to make a new line rect edge check. That's a new one that I want to kind of create. This line rect edge check is going to be basically checking edges as opposed to centers, and I'll talk about the difference between one thing and the other and how are we doing it today. We'll change the game object type to agent because right now it's ship, and I think we have an opportunity to create an agent type so we can have more than one thing work together. We'll create a find closest path node function, and this is all in hopes that it's going to help you with your move behind cover action. That's for assignment 4. Okay, so that's what we're working on. It sounds like it's not a lot, but there's some rework we have to do, and I think this lab will be a little bit simpler and straightforward in some ways than we've seen before. Okay, so we should be able to finish. I'm hoping we can finish early on this one. Okay, let's get moving. So what I've done online is I've got my Lab 10 Final and Lab 10 Starter. I'd like you guys to start with Lab 10 Starter. I'll be updating Lab 10 Final where you can compare my code with your code. All right, so I've got all that ready to go. And Lab 10 Starter is just the previous Lab 9B Final. That's what I'm using for the starter for this one. And then I've already posted this one here, but I'm going to be updating that as we go. So please start from here if you want to give yourself a challenge and, kind of code along with me. I think it's a good way of doing it. All right, that's fantastic. Let's move to the next part. So I've taken the liberty of downloading, and I'll come back to this in a second. I've downloaded my, assets already. So this is my Lab 10B. I've just downloaded it and renamed it to Lab 10B. And I've started it off inside of Visual Studio. So there's Visual Studio. And the first thing we always do, of course, is change it from x64 to x86. I'll give you guys a second to do that. And I'm just going to test locally to make sure that things are working out as they should. That's the first part. And let's see as this builds, how we go. Again, just to remind you guys that there will be no lab next week. I'm speaking to Alex. Chances are we're also looking at a true-false multiple choice type test, which I think will kind of pull the take the pressure off in terms of kind of the way we're doing things. Okay, so this is what we have so far, and there's some good things and bad things about this, and let me talk about the bad things about this. So let me use some annotations to talk about what it's doing right now. Okay, so I'm going to use the draw a line, and let's take a look here. So if I take the center and I draw a line from the center to the center, that has line of sight, right? Line of sight, center to center. How about this one though? Center to center, right? You can see it does not have line of sight. Okay, it does not have line of sight, but is it always center to center we care about? That's how we've been doing line of sight so far, center to center. And I think there's an opportunity for us to do something slightly different than this. So let's consider an alternate scenario. What if, and I'm just putting it out there, right? So we'll clear that one, and they're all drawings. What if instead of doing center to center, we did something that looked like this? So let's suppose I drew a line. So here's a couple nodes. If I did center to center, right, then that's okay, but isn't it better for us to do a line that goes from, let's say, the center of the node to each edge? Why is that? Because if you think about this, right, and if I go back to our actual live object here, so if I draw, and I'm just going to use the annotation here for a second, I'm building a better mousetrap kind of idea, right? So let's think about what I'm doing here. So here is my bounding box, let's just say, right? And I made this a little bit maybe bigger than I should, but whatever. And if I draw, so you go to the draw tools again, and if in this bounding area, if I draw this to the middle, you can clearly see that that is not going to go because it's going to hit with this part right here, right? But what about if I draw from this node that's red right now I'm going to draw this one to here. I clearly have line of sight there, which means that if I put a ship there, then I'll see the target, but I won't have line of sight. No, that's no good. So that doesn't work well. I want to be able to do it so that if this has line of sight with any one of the edges, so this one, look at that one, that even works, right? That's almost line of sight right with this. I mean, I'm cutting almost like a little triangle right here of an area that I have line of sight with. Same thing with this one. So this one here from middle to middle, no line of sight, but from middle to edge, line of sight, right? So that's almost like rays casting on the edges, which makes sense, right? And what about from here? No line of sight there. That's good. But from here to here, again, you see that there's these little kind of rays or swatches of information that are that makes sense, that I want to be able to improve our line of sight. So here is clearly no line of sight. So there's no line of sight here in the middle or in the edge. So that is a good one. There's no line of sight there. None, right? So that's okay. This one that says that's red, again, I can see this part and I can see probably over here. So look at that. That's like pretty good. So that one shouldn't be red. This one should be. This one should be. So there's some areas here that are, considerably not working well. Why? Because the way our line of sight works is middle to middle. That's how our line of sight works right now, right? Because we're doing a line rect check. We're passing through our target is the middle of the of the object, right? So there's a couple ways we can do this differently. If I want to, I could call line rect check a bunch of times. I could call line check a bunch of times by myself, but this is part of where we need to do our improvement, right? So I'm just going to clear all drawings there. Okay, so that's something that we want to think about. So this idea here is what we want to try and do. If we can cast a ray to the middle of this line here, the middle of this line here, right, and kind of almost it creates this triangle of goodness, if you will. Even if we from this node, if I can just barely hit the top of this one, considerably, we probably have line of sight to some degree, at least from one aspect of this node. So this would be a line of sight node. So why do I care about this? Because, well, if I put a ship there, so let's say if I just took the liberty of drawing another object here. So let's say, example, I had a ship that was here. So some kind of ship that was here. And I said, well, there's no line of sight there, right? And I parked behind cover. If I consider this cover, I actually don't have any cover, right? So that is a problem. Okay, that is a problem if I don't have any cover. Because then my player can clearly see my enemy behind cover. And if my player can see the enemy, then the enemy can be shot. And that's not what I want. I want the enemy to be hidden behind cover. And it's going to find the closest node with no line of sight. Okay, so that's the thing that we want to do. So that's the next part. So let's work on that together. And that's what the point of this whole thing is. It's not quite perfect. And I don't mean it, I don't need it to be perfect, but it has to be a little better than what it is. So let's commence with what it says here. We're going to improve our line of sight check. We're going to fix our line of sight bug, and we're going to do a bunch of little things, in quality of life improvements, so to speak. And I'm going to start off with my ship. So in my enumerations, I have this game object type.h. So it says, Miguel says, imagine that you are shooting you can see the enemy, but you cannot hit it. Annoying. Yeah, it is pretty annoying. But it's the other way around, where you can see the enemy and hit it, but it thinks it has cover. It doesn't. That's annoying. So the AI is not really perfect. So notice it says there's spaceship, obstacle, blah, blah. We use these for identification purposes. And so I'm just going to create a new type in my game object type called agent. Okay, so agent can be other things. It won't just be, they won't just be a spaceship. It won't be, one thing or the other. It'll be of type agents. And that's the first thing. So I've changed my game object type, or added a new game object type called agent. And what I want to do is I want to go to, and I did this in an enums game object type. I just added an agent type. You can put that wherever you like. And then the next one that I want to do is I want to go and look at our agent, which is inside of our decision tree. We have an agent called ship, and under the ship.cpp, we want to identify this thing as an agent, not a ship. Ship is a very specific thing. It's a ship, but I'm going to have more than one agent, right? Maybe different kinds of agents. So this is an agent now instead of a ship. I think that makes more sense. I'm going to keep ship because maybe sometimes I have a call for something like that, right? But agent is the thing that I want to put in it, okay? And that makes more generic sense. Okay, so that's our ship. So that's the first thing. So ship has been renamed as we've kind of added an agent type, right? So that's what we wanted, and check, that's done. All right, so how do we improve our line of sight function? Where is that thing? So if you go to scenes and if you go to playscene.cpp, and if I scroll down all the way to the bottom, pretty much, there is this check agent line of sight. Okay, that's where it is. And what I want to do with check agent line of sight is I want to make some improvements, right? One thing that we haven't done, a couple things, is right now our agent, it returns void, and I want to make it so that the agent actually returns a Boolean, right? So that way I could do some chaining with this as well. I can return the type that is returned when I check against the agent and the display object, whatever it is. So going back to my playscene.h, this is just for convenience. I'm just going to change my, when I check agent line of sight, I'm going to change this to a bool. Okay, oops. Change it to a bool, which means I got to change it here as well. So I change this to a bool. To return it properly, instead of having as line of sight down here, up on the top here, when I do my check agent line of sight, I'm going to initialize a little differently. And I'm going to say that I'm going to say it's a bool. It's going to be called as line of sight, and I'm going to set it to false by default. I'm also going to have my agent. This is where my bug was. My agent set as line of sight. Every single frame, I'm going to set it back to false. So when I first start checking, by default, I don't have line of sight, as an example. And this was my problem before. So this is I'm just going to reset at the top. Everything else here is okay. Again, it's a little messy, but it's fine. And down in here where it says auto has line of sight, let's just take this back and kind of say has line of sight is equal to whatever this is. Okay. And then finally at the end, I want to return has line of sight. That's going to be enable us to chain a couple things together or get the return type that I want. So that's something that I want to do. Also, one of the things that we're using when we check line of sight with the target is I have this like the end point. So we have a start point, which is the agent position, and the end point, which is where we want to go. The agent target is what I want to put there. So let's make a new little thing. Again, we can make as many variables as we want, and it's not going to save us any space or time to do less variables. So I'm going to say const auto, we'll say agent target, just to make it clearer, to make it a lot more clear than we did before. We'll take this whole thing, this piece right here, instead of putting it in one line, we'll take it, cut it, put it in there, and we'll take agent target and put it here. Again, just to clarify stuff and to make it so that has line of sight is on one line. Okay. So that's the first part that I want to try and do. Nothing different. I'm just reorganizing a little bit, and I'm making it so I reset at the top, which was my issue. All right, let's run it again, and this is the first bit. So let's try it. It's going to do his little dance in a second, and we should be okay. That was a long build. All right, here it is. So far the same, no problem. But what we're going to notice is when the ship comes in play, that's what's going to have the issue. Let's make the ship come in so we can test it. So again, I'm just going to go to the start function. And I've kind of commented out the ship. Let's put it back in play for now. All right, so there it is on line 97 or so. I'm going to put this back in play, and then let's try and see if I move the ship around this part. So again, I'm going to move the target down. So let's move the target down to here, let's say, and move the ship down as well. And then you can see that clearly there's an issue, right? One issue that we're having right now is no matter where we aim, right? Even though it looks like we have, we're good, we're not good, right? Because why? I'm resetting at the top and I'm returning it at the bottom, right? So that's one thing that we're having an issue with. If I come closer, let's say, for example, maybe I'm at the edge. So if I take my ship and I come closer in, so that's, let's say, over here, as an example, and again, you can see that that killed it, right? That's what that did there. So that what I did was I'm not checking for line of sight. One thing to do is at the top over here, every frame, I can go check agent line of sight with my ship and my target. So let's put that back in. 2 is the layer, Miguel. So I can say it's the second layer, layer 2, as opposed to layer 1. All right, so there is the ship again. We can bring it back in. We'll move this down to here. Move this down to here. And now it's working. And one of the things we want to check, I'm just going to move this up here for a second. And one of the things I want to do is if I move my, kind of my target, so my angle, you can see that it's going to work a lot better than what it was before. So that's something I want to do. Okay, again, a little bit, not so much control there, but it is what it is. If I move my ship closer or my target closer in, so let's say, for example, I move my target like over here, then you can see that clearly, as long as I dissect my target with my agent, right, then I can get line of sight depending on where the ship is. But see, sometimes you get this kind of thing going on where you're not quite, detecting line of sight. And why? We have another issue. Okay, we have another issue we're going to have to address in a second. All right, so that's part of it. So we've gone and done a couple things, and I want to continue. Where I want to do it is down in here. So we're still working on improving, kind of algorithm improvement a little bit. Down where it says agent, down in here, this loop here, where if my display object get type is equal to agent.get type, really what I'm trying to say here is if it's not equal to agent, right? That's one thing I want to ignore agent, and I want to also ignore PathNode. So I'm going to kind of put in both specific things that I'm looking for. Again, you can be as generic as you want, but I'm saying if it's not an agent or if it's not a PathNode, it has to be not one of these two things. And the target type that I'm looking at, the object that I'm looking at is not equal to the object type that I'm searching for. So for example, it's not something that I'm already looking for, the thing that I'm plugging into this up here as an example, then fine, add that to the list. Otherwise, don't. Okay, so that's what this has done. So that's why I added in agent and PathNode. Okay, so that's one thing I'm doing. Fantastic. And again, you're going to see the same effect. Again, we always want to check with what we have to make sure that it's not worse than what we had before. So again, if I move it down here, you can see that the nodes change around it. So this is good. And as I kind of come into play here, you can see that that was interesting. As I come into play over here, then you're going to see that we have a bit of an issue with this thing. So maybe it's too far or whatever. So I'm going to bring my ship a little closer, and you can see that as I bring my ship closer, I get kind of more of a definitive kind of thing where I can bisect this at different places. If it's too far, it seems to be that that's where I lose my line of sight, and that's okay. Okay, so that works kind of a lot better. All right, so that is part one. Part two is really, we have a very generic way of doing this thing. And we're calling this function called line of sight check. Line of sight check, if I go to definition for the collision manager right here, line of sight check, it uses line rec check. Remember we talked about this? Line rec check takes my start point and my end point, and it targets let's rewrite this function as well a little bit, because this is a little bit odd the way we're doing it. So, and again, I'm bringing this into play because I want to do, we talked about, make it work. I always say make it work. But then sometimes, we got to be a little bit, more progressive. And as we work, we have to kind of do some improvement, and we haven't done improvement for a while. So let's break some of this stuff down. Okay, so our rect start, right? That is this piece. That's our rect start. And when it's looking pretty ugly in terms of what this is. So let's do that next. We'll say auto rect start, right? And that's equal to object, this part right here. This is rect start. So right up to there, up to there. So I'm going to get this and put it in there, okay? And then put rect start in there, rect start. So I'm just making it easier for us to read. So rect start here is rect start there, okay? And we can make this probably a const auto, all right? Because it makes sense. All right, so that is rect start. Object width and height, we're going to do this a couple of times later on. So just to prepare, I'm going to do a const auto width. So I only want to calculate this once. It'll be object get width. So I'm going to put that there, and I'll put width in there. So again, just to clarify what this looks like. So I'm sending it to line rec check a width. And I'm also going to grab this part, and I'm going to say that const auto height is equal to this. So again, I'm just rewording stuff so we can see what the problem is. So there's our height. And I'm saying if my line rec check from start point to end point, where end point is me calculating the end, I calculate the end based on the direction that I'm pointing right now. And we don't care about the path node. Path nodes can point in any direction they want because they're omnidirectional. But where we have some objects like our agent that needs also a direction as well. So both direction and the target. Okay, here I only need the start point and end point. And here's the other thing. How do I identify what agent is looking? I have no way of identifying here when I go to line of sight check, right? I can't, right? I can't tell if this agent is the path node or the ship or whatever. I have no idea. I have an objects list. This objects list is basically my contact list, right? That's what this is. And I have my target. So target I have information about, but my agent that's calling everything, I don't. Let's add that in. Let's add the ability for me to get information from my agent. So again, save. I'm going to go to my collision manager .h and managers filter. So here's my collision manager.h. And what I want to do is I want to modify my line of sight check that I wrote, this one. And I want to change this, instead of making it a start point, I want to pass in the agent. Okay, so the agent. So, and we'll see if there's any other improvements we can make as we go. So it's going to be an agent pointer, which is going to be called agent. Okay. And what I want to do in my collision manager.cpp is rewrite this thing. So I need start point in a second. You're going to see it's going to complain. That's okay. So I'm going to say agent, right? That's what I want. But start point, there is no start point. Let's make a start point happen. So before our little for loop up here, I'm going to just add in a const auto start point just to fulfill our issue. Start point is equal to an agent and get transform dot position, right? So this is kind of what we're sending in here. Instead of sending that in here, I'm just going to rewrite it. So you send in the agent and I get the position for you. Okay, so that's something I want to do. And then when we call it from placing, we can't do it this way anymore. We're just going to send in the agent itself, like so. So now it becomes even sleeker. Look, agent target, contact list, object. That's what we're sending into line of sight check. where agent target is a vec2, contact list is a vector of display objects, and object is the target. Okay, so that is the stuff we're looking at right now. Okay, so this is pretty cool. I like it. It's getting better. It's getting nicer. Let's go back to my collision manager.cpp now, and we can clearly see that this is shaping up to be a little bit better. Again, object, we've kind of reworded everything, so it's a little easier to read. It's easier to read what we're doing here. So what we want to do is we want to say a couple things here, and I want to kind of, instead of doing it this way, where I check my object after I see if I've got a line rec check, I want to rather do it the other way. I want to see if this is the object I'm looking for. If my object get type, this one, is not equal to my target get type, right? So it's not the target that I'm looking at. It's something else. Target meaning that it's not the target. It's like an obstacle. Then I want, and if I have my line rec check that works, I want to return false. And I need this other thing that I don't have, which is my line rect edge check, right? Line rect edge check. I don't have that right now, and I want to make that. So let's go into collisionmanager.h, and underneath my line rec check, I want to make another one, static bool, and it's going to be called line rect edge check in here. I'm going to take a line start just like this. So there's line start, put that in there. And I'm also going to take I don't need a line end, right? Because what I'm going to do, just like I showed you in the diagram, is I'm going to calculate my end based on these lines here, the bounding lines, the bounding box, okay? So I'm going to say, hey, take the beginning and the end of this line, and I want to calculate the middle, and that's going to be my endpoint for this thing. So I'm going to calculate 4 different endpoints, 4 endpoints, as opposed to just 1. So I don't need my end line. So I don't care about direction in this case. It's not about direction. What it's about is I want to check my other stuff, my start, my rec start. And by the way, rec, I don't know what I was thinking when I was typing this. Let's refactor, rename. So refactor, rename my line rec check. Instead of rec start, let's make it so it's rect start. Okay, rect start. And that's in my previous line rect check. Okay, so it's a rect start, rect width, and rect height. And so I want to take these last parameters and use them again. So this is the same parameters, but I don't need my line end because, well, I mean, I don't need an end. I'm going to calculate my end, right? So, and I don't need this to be line 1 and line 2. Right, line 1 and line 2. I don't need that. I'm just going to call this like line start. Right, so this is the line start, and this is my rect start, my rect width, and my rect height. That's all I need. In fact, even these things can probably change. Line start, line 1. These things can change too. Might as well do that. So I'll refactor, rename. Since we're here, might as well just readjust some of our stuff. So again, line start. This will be line end. I'm changing the line rec check right now because I don't like it. I'm refactoring, right? Line. And this is something you would do with your engine. Like over time, you want to evolve things just like I'm doing. All right. Here it makes sense. Line 1 and line 2. When I'm checking min square distance between 2 lines, line, right? But here what I'm doing is I only have one line. I only have one line, here. So line start and line end. Line start here, but I don't need a line end. And this is my line rect edge check. Let's make that. So I'm going to go to here, and I'm going to generate my implementation. All right, so what is this wonderful function going to do for us? And how is it going to be really ugly? Because we're going to start ugly, and we're going to get better. Okay, that's how it goes typically for us, right? So yeah, here we go. Here's the ugliness. I want to borrow from my X and Y from my line start. So I'm going to grab these two things where it says line start. X1, Y1 is going to get, I'm going to get those from my line start. Let's pass those into here. It's going to be very similar, right? Let's try that again. I meant I only need this part, line start for x1 and y1. We're going to rename those later, okay? So I need those two things because I'm getting from line start, I'm getting kind of an x and y coordinates from there. That's what I'm getting from there, right? And then what I need is again, I'm rebuilding this thing right here, but it's going to be a lot longer. Then what I need is these last four things, okay? So I'm going to grab these things. And those are going to virtually stay identical. So these are going to be all the same. Rect start x, rect start y, rect width, and rect height. Notice also that I have these little marks here. A lot of times they tell us, even in my older functions, that we should put const. So let's put those in there. So we'll say const. We'll add those const in there. Since we're asked to do it, I'll do it. No problem. They're going to be const anyway. We're not going to do anything with them. We're not going to modify the original parameters. We're just passing them in. Oops. We're passing them in so that way we can use them, right? In a very, come on, Tom. There we go. In a very nice way. So that's what we're doing. We just made those consts. So again, it's just taking the same parameters that we got and we use these ones first. This is the first part. Now, what I need to do is I want to configure each line separately. So I want to configure the left line. I want to configure, this is just me doing pseudocode, the right line. I want to configure the top line. And I want to configure the bottom line. Okay, so what does that mean, configuration? I mean, I want to calculate the start and end of the left line, the start and end of the right line, the start and end of the top line, the start and end of the bottom line. I want to calculate those things, and this is based on the width and the height information I'm going to get. Okay, I already have some of this in here. I've already done some of this work. I'm just breaking this out and reusing it. Okay, the one from line rect check. Okay, and then what do I want to do? Then I want to do the same thing I'm doing here, which is the line functions for each line. So redo. So I want to do line comparisons, right, for each line. And finally, return true if any line collides with the edge, because that's what these are. Configure the left edge, the right edge, and so on. That's what I'm doing here. Okay, so that's what these configurations are. It's pretty straightforward, but we have to do a little bit of typing, and it sucks. But here we go. All right, let's do the first one. So it's going to look like this: const auto, and we're going to say left line start. Again, you can call this whatever you like. That's going to equal to what? Well, we know the left line is, we have a start here, right, as an example. And then we have, this part here. So this part here, this line check as a start one, line start, line end, and then, kind of the other line. So this is the line one start, line one end, line two start, line two end. Line two start is the edge, where it starts. This part I need, this part. Actually, I just need both these. So line two, these parts, I need those parts right there. And I'm going to grab those, copy them, and go over here and say something like, that's equal to this, but it's not equal to both of these. That is the left line start. And that's the left line end, which is this part. Just copying. Okay, that's all I'm doing. I'm copying from one to the other. And why? Why am I doing this? Could I write it in one line? Yep. But I'm doing it so you can see I'm going to need to do another calculation here, right? So I've done a line start. This is the left edge, if you will. So this is, instead of the left line, we'll call it left edge start. And this is the left edge end. So I'm going the left edge of the collider boundary, or the boundary box that we're making, right? That's the left edge and left edge end. What I want to do now is I want to calculate the middle. const auto, and it's going to be the left edge midpoint. All right, the edge midpoint. That's, remember we talked about hitting the midpoints every single time. And that midpoint is going to be actually a lerp, right, between the left edge start, right, and the left edge end. And we're going to calculate it based on 0.5. Remember, the t value is the middle, 50% between both of those two lines. We're going to create a new, this is going to return a new GLM vec2 object that's going to calculate the exact middle between these two lines. So that means, let's say, for example, my left edge starts at 200 on the x-axis and 300 on the y-axis, okay? And it goes to 200 on the x-axis to lower down, because it adds height. Let's say it's a height of 600 almost, or 500 on the y-axis, right? So I want to subtract 600 minus 300. I have 300 pixels, and I want to get a value between them, let's say something like 450. And that's what this function, this lerp function, is going to do. Okay, it's going to calculate it's linearly interpolating the middle between this line segment. That's the midpoint that I'm calculating. Again, there's lots of ways to do this. I'm just using the functions that we have available to us. Okay, I want to use the same idea, but I want to just copy paste a little bit and rename some stuff, because it's easier to copy paste than to destroy everything else. So this is right edge start, right edge end, and right edge right edge, what did I do? I meant right edge end and right edge midpoint. There we go. I could probably typed it better if I wanted to. All right, cool. So that's something that I'm doing. Yes, that's what I'm doing with the lerp. I'm calculating the distance divided by 2, but it's not just the distance, it's actually calculating the middle point, the midpoint between the start and the end point of the line. So the middle point of the line segment. Okay, this is wrong. We need to replace these pieces. This is right edge start, and this is right edge end. That's what this is doing. And I want to replace these two pieces with the stuff that I have over here. So this is this little calculation right here. This is the right edge, so that's for this part. And then I want to calculate this part right here, which is the other part, the end, which is that part right here. All right, so they're different than the other ones. I can't just copy paste and replace the RXs and everything else. They're slightly different. So that is the left and right edges. Let's do the top and the bottom. I know this is tedious, but it's part of it, right? So again, I'm just going to grab these lines here, and I'm just going to go here, and we're going to say that this is the top edge start. And we're going to replace this top edge end and top edge midpoint. And we'll say the top edge start and the top edge end. All right, so this is, and it's still we're using the same linear interpolation, but these values are different. So we're going to go up here, and we're going to grab these last two parameters, this one, which is this one, and this one right here, which is this one. Okay, so these are just changing stuff that we have. They look, if you notice, very similar to these, but they're using slightly different values for what we have, right? So the top one is the same, right? These ones are the same, but these ones are different. All right, last one. So again, grab all this, go to the bottom edge, and we're going to say that this is the, we'll call this the bottom edge start. I know they're long, but just, you know, just bear with it. You know, it's just relax and go through it. Some people would like to use smaller names. That's okay. But you know what? There's less confusion when I use the right name for everything that I'm doing. When you look at your code, you know, later on, a year from now or whatever, and you want to look and see what you did, you'll be able to identify some of this stuff. You'll be like, oh, okay, I get what we did here. Okay. I mean, commenting would be nice too. All right, so, and then I want to grab these parts here. So this part for this part, and this part very carefully for this part. And that's a lot of our work right there, right? So all I'm doing is calculating each edge endpoint. So the right edge midpoint, the left edge midpoint, the top edge midpoint, the bottom edge midpoint, I'm using those as targets for my line. So I'm, example, again, going back, I'm going starting here, and then I'm deciding each of these line endings from the original point based on the bounding area of the object, okay? The linear interpolation, the LIRP, is just basically finding the middle point on the line segment. Edge start, edge end. Line start, top edge, start, top edge, end. Right edge start, right edge end. Left edge start, and I'm finding the middle point every single time. Okay, so that's what this is doing. So this is done. Now I want to do the same things, the same comparisons we did here, but we're going to chop this down a little bit. So I'm going to grab this whole thing, and we're going to be putting that here. So, but now you notice that there is no end. The x1, y1, this is going to stay. This is kind of our start point. And if we're right, x1, y1, as an example, we probably can do like a start point for each of these instead of creating a new GLM vec2, right? So we could probably do that. And so what I mean by that is instead of getting x1 and y1 and doing a GLM vec2 here, that's really our start point that we're putting in there, which is line start. That's really what it is, right? Line start is x and y coordinates. Line start x and line start y is what's going in here. So we could do that, but it's okay. This part is what we have here. So notice that this is the edges. This is the end point. So this is the left edge midpoint. That's the end. Left edge midpoint. This is the right edge midpoint. Right edge midpoint. This is the top edge midpoint. This is where it changes, right? This is the bottom edge midpoint, okay? So that is left, right, top, bottom. And now we have to fix these ones. This is the left line start, right line start. So I can, instead of redoing all these, right? I could leave them, by the way, they work fine, but I've already done them, so I might as well just replace them so that they're clear. Left edge start, left edge end. I don't need to do this, but I'm doing it because it's just easier and it kind of clarifies what I'm doing here. So left edge start, left edge end. Again, you don't have to do this. We could have left those other ones the way they were. We already calculated the most important pieces, which are these pieces here. And top edge start, top edge end. I'm just pre-calculating as opposed to, doing that over and over again, right? And bottom edge start, and bottom edge end. That's all these are. Okay, so it just makes it more clear. So that's what these do. They basically generate a Boolean. They do a line check. We kind of do 4 line checks for each edge. The exact same thing we did for our line rect check. Finally, what we want to do is similar to what we've done over here. We want to take this part, and we're going to put this over here. Again, very similar to what we've seen before. Otherwise, we're going to return false. And that is our line edge check. I'm going to save this and put this up on GitHub, so that way you guys have a chance to take a look and compare my code to your code. It looks like a lot, but I've just named everything. I didn't have to. I could have just done these, right? But then you would have to sub in all those ugly numbers in there, and I don't like it. Okay, so again, it's a little wordy, but it's fine. And let's put this up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. And I'm going to say, so I'm going to add all these changes to the staging area. Yes, save. And I'm going to say, sure, added, which is the new line rect edge check. Added line edge, oops, line edge rect check function, which is what we did. Right, so commit staged, home, sync, and push. Okay, so that's what that does. And what the line rect edge check does now for us, it doesn't care about the ending. It only cares about the start and the rect start, where the rect starts, and the rect width and height. That's all it cares about. So now what we can do is, once we have this little function, we can go back to our line of sight check, which is way down here. There's our line of sight check. And now we can start rejigging this line of sight check to make it a little bit clearer. All right, so what do I want to do? I want to reverse the way this is done. So I want to say something that looks like this instead. I want to say that, let's bring this out here. So I want to say that, okay, what if the object get type, right, is instead of equal to, if it's not equal to the target, okay? If it's not equal to the target, so the object get type, I'm looping through each object in the objects list. The objects list is, I want you to think about this objects list as contact objects, things that I'm contacting with. Things in the display list that I have contacts, or other colliding objects, potentially. That's what they are, right? So if the object I'm looking at is not the target, that's what I'm saying here. It's not the target object, whatever the target is, right? Then I want you to do a regular line rect check, this regular line rect check stuff. I want to do that. And let's just take this part, okay? And I'll copy it. This don't cut it. I'll copy it, put it in here. So I would do a line rect check if my object type is not equal to the one I'm searching for. It's not my target, it's something else. If my line rect check works, well, that means I'm returning false, my friends. Why? That means I've collided. This thing means here that I've collided with an object that's not my target, which means if I'm colliding with an object that's not my target, I don't have a line of sight. So that's what this means. That's why I'm returning false. So if Ray is colliding with an object that is not the target, right, then return false. That's what this is. And when I mean my ray is like my line of sight ray. Okay. So that's this first part. I don't need this anymore. Okay. Else means that it is the type that I'm looking for, right? So in this case, there are two options. One of them, if I am connecting with the agent, and the other one is if I'm connecting and it's not an agent, it's actually a path node, okay? So I want to check to see if it's the agent first. So if agent get type is equal to agent, if I'm the agent, right, that I'm checking, double equal, please. That means that it's my ship or some other agent in the future that has connected. If the agent that actually is shooting a ray, so if the agent is an agent type, okay? Else, I'm just trying to rejig this, right? So you can see the situation here. Else, it's not an agent type, right? So not an agent type. which means it's a path node or something else. Again, we can think about maybe doing this a little differently, but let's see if we can optimize that later. Okay, so there's two types of checks we can do. If it's a regular agent type, I need a start point and an end point, which means I need something that looks like this, right? And we can do a line rect check with the start point, end point, the rect start, width, and height. That's why I did all this wonderful work here ahead of time. We can plug in here. We're going to return true. Okay, so if it's an agent, I want to do this kind of check. And if it passes, I'm going to return true. Okay. However, if it's not an agent, right, if it's a path node, something that does not require direction, an agent requires direction. So requires direction. So like some kind of, I have a direction I'm looking at. The agent, not an agent, which does not require direction. So for example, if it's a path node or something else that's 360 that I can see in every direction. Now, I don't want to do a line rect check. I want to do a line rect edge check. Line rect edge check. And where I don't need the endpoint, I just need the rect start point, rect start, width, and height. See how nicely it plugs in? And that's it. And then what happens if I don't collide with anything? Then it's going to return false. And that is my rejigged line of sight function. Are you with me? Do you get what I did? So there's two types, right? There's two types of agents. First of all, I check to see if the line of sight ray is colliding with an object that is not the target. So it's not the target object. It's like an obstacle or something, right? That's what this part does. If it's not the obstacle, then return false. I've hit something that is clearly not the obstacle, not the target. Let's return false. Else, let's now check if it's not this, the object type is not this, it is the target, but now we got to check to see if our line connects somehow, right? And we're going to see that if my agent, I'm going to check to see if I do my line rect check, but there's two different types I can do. One that requires a direction, which is kind of like this one, and one that does not, all right, which is kind of like this one, okay? We don't care about doing a non-directional check on an obstacle. We have to do a directional check on an obstacle, all right? So that's why we need a start point and an end point. All right, that's good. Let's check it and see what it gives us now, if it even works, right? Because that would be bad if it didn't work, right? Let's see, maybe I messed up, who knows, right? So it shouldn't affect anything. It should be the exact same way. So nothing should change in terms of the way this works. So what I'm doing is I'm always checking to see first if we have the same effect that we had before. We shouldn't see that there's anything different in terms of our quality, that we did before. If I move closer to the ship, you can see now that if I zoom in or out, the same thing is going on. So the same checks are working. That means we did good. Okay, that's what it means. We did good. If we did this and it works okay, then it's okay. And what I've done is I've updated my line of sight check. Let's put this up on GitHub. So home, changes, and I'll say, let's add those changes in there. And I'll say updated line of sight check. Okay, so I've added some additional functionality. We don't see it yet, but you will. Commit staged, home, sync, and push. Okay. Home, sync, and push. Awesome. All right, fantastic. That's great. Now, I want to rejig my my edges so that, well, first of all, let's see what we've got here. Do we have the proper stuff? Let's see what the difference is. Does this look better, worse, the same? What the heck? Right? So that's the first thing. So let's do some checking of this thing to see if it's better than it was before, or if it's the same. Like, did we do anything that improved anything, or is it like worse? Is it better? What do we do? Let's use that annotation stuff to see if there's any change, because that's the one thing we want to try and do. We want to try and do these edge rect checks. So here, okay, look here. Let's first draw. Sorry, let's first draw a bounding area as best as we can around this thing here. So this is where the bounding area is. Okay, so that's the kind of idea. This is the same check we did before. All right, now let's check and see if, all right, I draw a line from this point to this. Can I still see it? So what happens? I should have line of sight here, and I should have line of sight here. So what did I do? I didn't really do much, right? I mean, I went through all that trouble. I did the line check and all this kind of stuff. What am I missing? How come this doesn't look quite as good? So this one should be green, actually, and so should this one, because at least one edge is kind of good, right? That's the idea behind this. This is the troubleshooting that we're going to do for the rest of the time, right? So what is the problem is what I'm saying, right? So that definitely should hit this thing, right, as far as I can see it, because it's here and also it's here, right? This one definitely has line of sight to there, and this one has line of sight to there. You can see that all these ones should change when it comes down to like the edges, right? So this, I'm doing edge checks, right? So I should be able to collide with all these edges. So what can we do to improve the checks? How do we check to see if we made a mistake? What did we do? Any thoughts, my friends? Because that didn't really do much. I mean, it looks okay, and you know, certainly what we can do is we can move the object around. You can see it looks somewhat similar to what we did before when it comes to it updating the position, right? So we can see how it updates everything, right? There we go. But we're not getting what I was hoping to get, right? Because, okay, obviously this is okay. In this situation, we're good. There's no line of sight. Let's do it again. I just moved it around. Let's see if there's any difference. In this situation, how about this one? How come there's no line of sight for this one, right? Because it's pretty close, right? So let's see if we can annotate again and draw a line. What could be the problem? So if I'm drawing this to this, you can see again, I have here, I can get there, right? I can't get there, but I can do here or here for sure. Look. Check for only center. Well, that is checking if I'm doing what I'm doing. So am I using my, am I using the thing that I'm supposed to use, right? You see what I'm saying? Like, am I doing the things, is my function being used? So that's the first thing. So let's see if I'm actually using this piece. Let's follow the logic here to see if it makes sense, because this is a little bit convoluted. Maybe we can simplify this, but the idea is correct, right? So I'm returning true if I have a line at rect edge check between my start point, my rect start, width, and height. Cool. I like it. All right. Well, let's do it. Let's see if that makes sense. So I want to do a standard cout. Let's see if I get here. And we'll say something like doing a line rect edge check. That I'm performing that check. We should be doing it in some places. Okay, so if we don't see something here, then we know this is failing somehow with our checks. So save and run. Troubleshooting 101, right? And doing a line rect edge check. Look, I'm getting a bunch of them, right? This is good. That means it's going through my function I just wrote. Okay. So that's good. That's a good sign. I like that. So it's getting there. Definitely getting there. So it's saying, okay, so it's the agent type. Let's undo that change. The agent type to get in here is, it's not an agent type. It's a path node. So let's print out the type that we have, right? So we'll say game object type. Let's see what it is, right? And we'll say that is the type. So game object, so the agent dot get type. Okay, that's what that is. And I want to pass that. Is there a toString method that I can use? Can I do a toString method here? Because I want to convert that thing to a string. Well, no, we know what the type is. We're looking for a number. That's what this is going to produce. So the agent type is a number. And if I look for a if I go to enumerations and I look at game object type, we're looking for 0 as an agent. And if it's a path node, it is 7. Let's make it so that it's a little easier. I'm just going to move this around. So cut. We'll make it so that it's 1. How about that? We can make it wherever we want. It doesn't really matter. The compiler doesn't care what numbers you're using, right? It's just convenience for us. So 0 is agent and 1 is path node. What type am I looking at? Agent or path node? 0 or 1? What should it be here in here? Not an agent type. It should be a 1 that I'm getting here. It's a path node. Let's see if this works. So again, let's run it. We're checking to see, we're confirming what we're getting here. And I'm not doing breakpoints. I'm just doing one thing at a time, just to see what the problem is. We're troubleshooting that this is working. We're going to do more troubleshooting here. Okay, I'm just rejigging. It's rebuilding. Hopefully you guys can see the error. Okay, so game object type is 1. They're all 1. So it's all path nodes that are checking here. Path nodes is the ones we're checking. Yay. So for each path node that's passing through this thing, for each path node, so for every object is a in the display object list, every contact, right? We're looking at all objects inside of the list for every list object, and we're looking for each agent. Remember, line of sight check is happening for each agent in the list. Each agent meaning every path node, because path nodes are also of agent type, right? That's what they are. So that's what's happening. And so for each path node, we're going in here and we're checking to see if it's true. It's saying it's true that this line of sight check for all the path nodes that pass through here, they're all true. There's other ones that didn't pass through here, as an example, and they're false. They didn't make it. Okay, they failed to check. All right. So now we know this is working. Okay, let's go to definition. So what is the difference then? What do we do? Did it actually help at all? That's what we're trying to say, right? So what does this line rec check do? Here's our start, right? X1, Y1 is the start of the line, right? And the start of the line is going to be the start that we're casting from, wherever that thing is, the start of the line, okay? And this is for every node in the on the screen, okay? That's what this is. So this is a start, left edge midpoint. Left edge midpoint is a lerp between our left edge start and our left edge end, okay? And then that is a line check, okay? So what I want to find out is why is this, because any one of these, if my left, this one is true, so if I've got to check here, or my right is true, or my top is true, or my bottom is true, any one of these can be true, right? Where I have my left edge midpoint as the target, that's my target, right edge midpoint, top edge midpoint, bottom edge midpoint, right? I'm using this thing. My line rec check is the next thing I want to check to see if it's going to make any difference with what I did. Let's check line check. So go to definition, line check. Okay, let's see what this does. So here's our line 1 start and line 1 end and line 2 start and line 2 end. Okay, and now we got some complicated stuff going on. So I want to calculate the distance to intersection points. That's what this is doing. So what this is doing is for UA, right, and UB. So if UA and UB are between 0 to 1, right, that's what this is saying, then we have a collision type. And this is a standard equation, guys, for collision detection. We know that it works. So this is the line. It's kind of funny and ugly, but this is a standard thing. If you actually look online, you'll see the exact same equation in a number of places. So there's nothing going on here. It's not that we're not doing the line rec check. It's just that there's no difference between this one, line rec check, so far, or not significant difference, and line rect edge check. There's no significant difference between the two. Okay? Why is the question? Why? Right? So there's only going to be a handful of these we can go through, right, as an example. I want to know when we pass through this and we get a result, when we pass through this part and we get a result that is false, okay? I want to look at that false result, right? When I want to print out the node that is false. So I want to say here, I want to say else. So return true, right? Else, then do something else. What if this is wrong? I don't need the else, right? So Catherine says, is there a problem where the line is coming from the X1, Y1? Well, it could be. It's definitely something we could figure out for sure. But we want to look at each individual node in a second, and we'll get there. We're going to do some stuff. So this is where I want to do the else part. So I'm just about to cancel out here, and I've got a false result, right? And I want to do a little cout. So standard cout, and I want to say results. So line rect edge check results is false. So when they're false, I want to know. It's going to be a lot of them, right? But we're going to switch to see which ones they are. We're going to keep on switching until we see those specific cases. And this is a little bit tedious, but there's not a lot we can do, all right? So this is what I want to do, and I want to put a breakpoint on this thing. So when it's false, it's going to stop. Let's run it. So breakpoint, remember in the gutter, what it does is it's going to give us information about other things, left, right. I can check each one of these later on. All right, and we can also check things like the line start and line end, like that what Catherine was saying, right? So what? Guys, look at this. How is it that we never stopped? I mean, it's got to get to this point, hasn't it? It's got to get here somehow, where we have this thing. Well, how can it not get to this point? How is that possible, right? That it's not getting to this point. I'm mad that it's not getting to this point where it's returning false, right? It's like it's always returning true. When it comes to this point, one of these things is going to return true. Well, if it's returning true, that means that this line rect check says, yes, I have a collision. If I have a collision, that means then when I go back to my placing.cpp, sorry, my other thing down here, if type not target type, right? All right, but yeah, but it's never getting here. It's never getting down to this. Okay, let's do a check here. Let's put a check there and see what happens. We get to this point. We're going to see a lot of true ones. Right, let's see what happens there. So we're going to run it. And yeah, sure enough, now we have a check, right? And we can start checking a bunch of stuff. We can see that left is true, right is true, top is false, and bottom is false. So this is the first one that we're getting top and right true, but sorry, left and right true, but top and bottom are false. Okay, which node is this that we have something like that? Well, look, here's the node 200, where x1 is 200 and x2 is 600. So I don't know if you guys can picture what that is. That is our ship, my friends. So I'm casting from 200 and 600. That's what this is. 200 on the x-axis and 600. Well, actually, sorry, 600 on the on y2. So on the y1, 200 and 300 is our ship, x and y. Our target is 600 on the x-axis and 300 on the y-axis. So, okay, cool. I like this. And we can maybe back up. Let's back up. We don't have information on what is casting at this point in this line rect check. We have no idea what that is, right? However, we do know that each of these lines check out in terms of our, when I'm checking lines. So I don't know which one it is. One thing we can do is we can certainly inspect each of the lines to try and figure out what each one of these things are, right? But this is just data. So we're not getting a lot of information from here. Let's stop. But we did do that first one. So we actually go to the true part, okay? Let's go back. Let's go back. I want to know when I come to this point now. This is inside of my, so I did those. What about when I do this? So inside of my line edge, rect edge check, when it's true, when I come to this point and it's true. So left, right, top, and bottom, any one of these is true. I want to check. Let's try. But again, I'm running it, and boom, it says it's true. Left is true, right is true, top is true, bottom is true. So where everything is true, okay? And we can see the information, right? We can see that the line start X is 500. So 500 across the X-axis, that's way on the right side. And Y is 20 on the Y-axis. That's the top right corner. That's really what that is, kind of the top right corner of the screen. And it makes sense that from that position to the target, which is rect start and rect start Y, 580 by 280. So on the X-axis, 580 is where it starts, and 280 is on the Y-axis. So 600 by 300 really is what that is. 600 by 300. Where is that? My friends, this is the target. And it's always going to be this. The width and the height are 40, right? And then I try and calculate. Now, this is the linear interpolation stuff that I was going to show you. So look, 580 and Y is 280, right? See this? 580 and 280. Left edge is 580 and 320. What's the linear interpolation of the left edge? 580 and 300. Does that make sense? Something between 280 and 320 in the middle, right? The middle value should be 300. We got the right values. So we're getting the right value for this. How about this one? 620 and 280, 620 and 320. The middle value should be like 300. There it is. Okay, how about this one? So it's working. Our algorithm is working. Our LERP is working. 580 and 280. Okay, whoa. That's the top edge. And the top edge end is 620 by 280. So these stay the same, but these stay different. So this should be something like 600. There it is. Okay, and the same thing for the bottom edge, 580 and 320, 620 and 320. The middle one should be 600, 600 and 320. So we're good. So these are all good. These are all true. And that top edge worked. Let's continue. Okay, what's the next one? This is 540 on the right and 20. So it's counting back from this one. Let's keep going. 580, 620. That's on the right side. So we're getting all the ones on the top right. And we're going to continue a bunch of times. Just going to continue a bunch of times as we go, because I want to get to those edges that are not good. All right, so left line rect edge check is 580 on the x-axis and y is 140. So that's somewhere down the line. Let's get that information. Y is 140 is further down. The one I want to see is something like around 200 to start, okay, which is going to give me false. By the way, you can see the false, true, false, true, true, true. False, true, true, true. What does this return true? It returning true. We stop here. We're only stopping on trues, right? So where one of these is true, then this whole thing is true, but not false. Okay. So that's something of a sign here, right? Like, what is this value? I could set up a Boolean up here before we set things up. For example, something like the state, if you will. So I can start off with the Boolean. We'll call a new Boolean that will say, we'll call it state. We'll start it off as false. Hear me out for a second. For testing purposes, we'll say that if we're here, then the state is true. Otherwise, we're going to return state. So state is the thing that we want to check. If I want to say that the state is false here again, I can do that, right? But the problem is if I did that again, then when we go here, then, as an example, we'll never get to this piece. So let's move this thing to here, this check. And now I can see both when it's true and when it's false. Let's try this again. Are you getting me what I'm saying? Before I was returning, I was like leaving the function. Now I'm not going to leave the function until I come to this point, right? So we'll see when it's true or false. Let's see if that works. So again, run it. Okay, and we're here, and the state is true. So true, 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 true. We can check all the ones that are true. And then we're going to chip on the one that's false. I want to see when, if ever, this is going to have false. We don't have a lot to go through. And I'm showing you something that this is part of our troubleshooting, okay? Our troubleshooting steps, right? So let's keep going through. Remember, any one of these can be true for it to be true. So there's a high probability that we're going to have line of sight unless it's blocked somehow, okay? So we're true, true, true. Keep going. What could it be? You can see that we're good, right? I mean, how many of these do we have? We have 600 of these, right? So it's not long, but you can see that there's a pattern that's emerging. And also, let's take a look at where we are, right? We're at 700 across the x-axis and 340, kind of in the middle. Everything we've checked so far, and we're kind of halfway down. Remember, there's only 800 by 600, so we only have to go to 600 here to see what this is. This is the beginning. So we're almost done. Like, you'll see what I'm talking about here. What do you see the problem is here, guys? Everything is true. Everything is true. Everything is true. Right? Think about what this is doing. Everything is true here. Because one of these is true, all of them are true. That's what we're saying, right? And you can see that we're checking each one. There's a false one, but it doesn't matter. As long as one's true, we're good, right? As long as I have one edge that's true, I don't care. It's going to hit the other edge. And they're the right edges because they're looking at every single edge that's good. So is this the problem is what I'm saying, right, as we go through. Again, it's a bit of troubleshooting, and sometimes you get to this point where you're going to get tired. You're like, wow, man, I've checked everything. It doesn't make any sense, right? But this tedium, so 460 by 500, we're almost done. Got to go a little lower, right? So we're just going to keep checking. It's going to shoot through. Remember, this is also going to check every frame. So this is the first frame, 580. We just want to go to the bottom. It's going to repeat in a second. But what do you notice? Everything is true. Every time it comes to this function, it never goes false. Never, 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 right? It always rings true. When I'm coming here and checking, it's like it's constantly true, no matter what I do, right? Okay, and then when I look here, right, as an example, we're just going to, you can't see it, but on my chart, it's the exact same. It looks like there's no difference. So you can't see it because on the other screen here, I can't bring it across. But at the end of the day, there's nothing different. It all rings true every single time we come in here. That means that when it's not coming in here is the problem. When it's not coming in here, all right? All right, and Sinan says, or if the type is not target type, okay? Remember that this is line rect edge check. We don't need a target. We don't need a thing. We're going to calculate the target. All right. Well, where do we do that? We do that down here. This is where we make our decisions. All right. So we say, to simplify, okay, if the object type is not equal to the target type is what I'm saying. Okay, so some complicated stuff here, right? Is there a way we can rejig this if else stuff so we can make it better? What would you do? Remember, we just wrote it as we went, and I want to be able to check through this to check it out. What's another pattern that we can use here, guys? Programming 101. What's another pattern we can use here that does something similar that we can check? What other things can we do? A while, but that's just changing the for loop. That's not really going to do. Switch case, Catherine, thank you. That's what I was looking for. How do we use a switch case in here instead? Let's comment this out, right, as an example, and we'll use a switch case. Now, switch cases are tricky because sometimes they give us good results and sometimes they're actually a bad thing to use. So let's go to a switch. So what are we switching? So we're saying switch on target get type, right? That's what we want to say. Whatever the object that get type is, we can switch because object get type, right? This is going to produce a game object type, which is 0, 1, 2, 3, whatever the enumeration is going to be. So now we can start thinking of cases. So case, if it's a agent, then do something, right? Case if it's an agent, then do something. What other cases are we going to have? Right, so case if it's an agent, do something. Case if it's a path node, right, then do something else. We know path nodes are different than agents, okay? Path nodes. And then it's everything else. If it's not an agent and if it's not a path node, it's something else. The object is obviously something else we're looking at, right? Example would be the obstacle. We can search for this if we want because those are the only ones we care about right now. Obstacles, agents, path nodes. We could, but that would make us very specific. We can also use the default case. We could say default. If it's something else that we don't know what it is, then do this. These are the three cases that I can think of. Something else, an agent, or a path node. All right. So which one of these checks do we want to use if it's an agent? If the agent is the one, then I want to use the regular, do we need an obstacle case? We can put it in if you want, or we can just let it kind of get caught here in the default. That's like an else, right? Default is an else. So let's think about what agent does. So if it's an agent, right, then it's this one, right? So I want to do a regular line rec check. So copy this, and I want to put that in here. Again, a little bit easier to read and than we had before. So we can do some stuff we had before. We'll comment this part out because that's what we want to say there. Oops, undo. Oh no, that's okay. It's not really what I wanted, but that's fine. Okay, so if the line of sight ray is colliding with an object that is not the target, right? Well, this is not true. This is if the line of sight ray is colliding with an agent. If the agent, line rec check, so the type, the object get type is an agent. Think about this. That means it's like, should it be even an agent? Should I even have an agent in here? That means my ship is the one that my object that I'm checking. It's a ship. I shouldn't even be checking the ship. So this shouldn't even be a thing, right? So this shouldn't even be here. Why? Because if you look at my player placing.cpp, the only objects that get loaded or pushed back, right, in the check agent line of sight, the only objects that get pushed back, and again, we can use a switch case here as well to make it better, is either if it's not an agent, if it's not a path node, then push back the object into the contact list. And that contact list is what we're going to pass into this. So there's no chance, zero chance, that it'll be an agent or a path node that we're checking here. Think about this for a second. There's zero chance it's an agent or a path node. Zero. Okay? If there's zero chance, then our contact list that we're passing in, remember, we only have obstacles and a target. Those are the two things we care about. So either an obstacle or a target. Let's go back to that thing we were just doing. Can't be an agent, can't be a path node, which means it's either an obstacle, like we said, or a target. Okay. If it's an obstacle, then if we do a line rec check, then this should return false because we've hit an obstacle, right? If it's the target, and we do a line rect edge check, this one, right? This is what's making it easier for us to see. Then, oops, then it's returning true. Why does this make sense now? First of all, it's way easier to read here, like super easy to read. If it's an obstacle or a target. If it's something else, we have an error. So this is an error. Something else. We didn't even know that there shouldn't be anything else. Let's print out what the type is down here, right? How do I move lines back? Undo. So again, I would do a standard cout. If it's an obstacle, we can say it's an error. We shouldn't have this at all, right? And plus, we want to add in the obstacle type. So object get type. We want to know what is coming out here. We shouldn't have anything else that's printing out, right? It's an error. This shouldn't happen. Okay. And now we don't need any of this, but we're going to keep it here because, you know, we don't know if this is right. Let's see now what we get. So we don't have any breakpoints. Remove the breakpoint. And let's see if we're getting any better than what we had before, or is it worse? Is it worse? Is it better? Is it the same? What does that look like to you? Worse, better, the same? Well, let's do our check. Can I do a line check between this and this? I can, right? So obstacle, if our target is an obstacle, I want to do a line rect edge check. If the target is a target, right? I want to do a line rect edge check if it's a target. So let's do a drawing and see if that works, makes sense. And then we'll look at other things. Okay, so again, I'm drawing this line from here. I can go to here. Yes, it's red. But to here, that looks okay. And what about here? That's not good, right? So this is actually good. This looks like it should be red here, but this one, it's like barely red. That's barely red. That's actually not bad in terms of how it looks. That should be red. How about this one? This one looks though that should be green. Again, I'm going from the edge. Let's undo those changes. So let's go from the middle of this one. I know it's kind of hard, but kind of go from the middle because that's where we're going from, shooting from the middle to the top edge. See, I see that there is definitely something that's wrong here because that should work. And this one, I'm just checking random ones. This one here, right, from the middle to the left edge should definitely work. Look, from here to this, right? Okay. So not much better. Not much better. Okay. But we're getting somewhere, right? We're reorganizing. I think one thing we're doing is we're trying to rejig some of this stuff, right? So we can make this clear. This isn't any good. We can get rid of all this. That, by the way, the stuff up there is just better. It's just clean. Do it this way. Would you agree? Just easier. Look at that. Like it looks better. And we're talking about algorithms, right? We're trying to figure out better ways of, you know, creating our use cases to make sure we never got an error. At least I don't think I got an error. Let's see if we got any errors here. What's one thing we never checked? So let's see, do we get any errors? So no, we never got any errors. There's no errors that we got. We never went to that default case. That's good, right? That would be bad if we got an error. All right, so let's do something else. Let's check to see if we still got the same functionality from our ship. We didn't check that, so we're going to move that down here. And we're going to move this down there. And we should light up like we've done before. In the past, it does. There it is. It's not great, but it does do its thing. So here, move the ship closer. And we can see that if I do one of these, wait a minute. That's wrong. Look at this now. So all of this is green. And that's not supposed to be green anymore, right? That's not supposed to be green anymore. That's supposed to be red, right? This part here is supposed to be red, but it's green. That's a problem, right? So we missed something, right? Let me undo those comments for a second. Great thing is we can just undo. Well, we want to do this. We say, okay, if it's not a target type, so it's not the target, okay? It's not if the object type is not equal to the target type, so it's not this, it's an obstacle, right? Then we do a line rect check. Else, if it is the target type, this is the target type, all right? But if our agent is an agent type, we don't want to do this part, right? What we want to do instead is we want to do, sorry, I'm just, what we want to do instead is we want to do this check, the regular line rect edge check, like the regular one, this one. That's if our type is an agent. So in case it's a target, yes. But what about if our agent is an agent type is an agent, not a path node that's checking? So there's two things going on here. The agent is something we have access to that we've just not used, right? So let's fix this part. That means inside the target, yes, this is good, but only if and only if it's not an agent type. So let's do another switch case. We can do actually a switch case within a switch case, which solidifies stuff, right? If our agent get type, right? That's the switch case we're doing, so a nested switch. By the way, one thing that I recommend highly to you guys is if you're doing a switch case that's nested within another switch case, use curlies, like so. You can do that, right? It's not going to hurt you. It's just creating another context. So I want to put this inside of the curlies, like this. Remember, you can use curlies by themselves. Even though you don't need curlies here, sometimes it's a good practice just to put them in. We need the break. That's something we need there. We need a switch case. And here's the cases now. Okay, so we're using the same switch case. Case if the agent type is a path node, right? So that's one type. And let's do break. Then do something, right? And case if the agent type, I'm just making this nice so we can see it, is an agent type. That's a ship. Then do something else. And if we have some other default case, which we should put also in here, because it'll complain, then it's an error. This is an error again, another kind of error, right? So when does this happen? Line rect edge check. That is only for a path node type. So we're going to grab this part, cut it, and put it inside here, and paste it. So that is the path node type. Okay? Because we don't care about the endpoint. It's a path node that's looking. Okay? However, if it is an agent type, then we want to use this thing right here, except we want to flip it to true. So this is very similar to what we had down here, but I think this is a little bit more clear. Very similar to what we're doing with a state machine, right? Does that make sense? So this is what we're looking at. So this is maybe a bit of a fix. Let's see. We'll put the error back in there. We don't know what the type is. If it's some kind of really weird error, then I want to know what the agent type is. Agent type. Okay. So I want to know what the agent type if there's an error. So it's an agent type, or if it's an object type, we should be able to get in there and know what this agent type is. Okay, excellent. Let's try this out and see what happens. So run it now. Again, this other stuff is commented out. And let's see if we have any better results for this guy, right? So one thing to do is just to rotate them. So if I just do this, it should be all red. Nice. that fixes that problem. Let's move it down and let's move it across and let's rebound. Oops. Yeah, that's clear. That worked actually. Not really what I intended, but it's okay. And now you can see that that works over here from this angle. Nice. So that only works when we have it. And so now I fixed the ship type, but we still don't have any better from this piece. Okay. So we said everything's clear. Like we went in here and we're now a PathNode type and we're doing a line rect edge check, but we're no better off than we were before. That's what we're doing. So we're kind of shooting these lines in here. But the great thing is that I can check for each path node, and I can specifically look for a path node that I want to check. Okay, so let's figure this out now. So if I run this, and we want to check for a specific path node that I want to stop, right? So here's my stuff. I want to look for this path node. So how do I figure this one? How do I do that, guys? I want to look for this path node on the screen. Not anyone, just this one. Okay, or even this one. Doesn't matter which one you choose. Or this one. Okay, how do I do that? Well, we can figure out the position, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 10. So the 10th path, the 10th row, sorry, 10th column, right? And row 5, you say? 0, 1, 2, 3, 4, 5. So 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and row 5, right? Okay, how do I get that from the grid? How do I get this from the grid, right? When it's that path node, how do I get that information from the grid? And do I have access to the grid, right? So remember that line of sight check is inside my collision manager, right? I want to know when it's coming in here as that path node. So that's happening in the placing. So when I loop through, right, and whatever, and I'm checking that line of sight for each agent that I'm checking, I want to check to see if that particular agent, which time it is, I want to see when that is, and I want to get information. I want to get the x-axis and y-axis information, the positioning, all right, of that thing, and I want to be able to see everything when I get in there. All right, so that's when I want to go, because that is my issue. Again, you can troubleshoot this. It's very subtle what the issue is, but notice we're never going to get in here. That's not going to be inside of the object list. So the object list is not going to trigger. So that means that inside of the CPP again, that it's not going to be an obstacle, right? It's not going to be something where it's an obstacle or a target, okay, or anything else other than an obstacle or a target. Remember, when we run this thing, we don't get any errors. I don't get something that says on the console, we don't get an error. It's something else. We don't get that. So it's always either an obstacle or a target. That's why these enumerations are great. Okay, we get this information. But what about you know, what the issue is? Can you guys troubleshoot? Can you figure out what that is? What the problem is? It's hard, isn't it? Right? Why? Because when we get into the target, we know we're aiming at the target. It's in the problem is in here. Okay, that's the problem. But when I get to the agent type, right? Here's my agent type. All of them are path nodes. All of my path nodes are path nodes. All my agents are agents, right? Which is my ship. So I'm using my ship line rect check. My line rect edge check, wow, this should totally work every single time, because every time I go there, it's true. Every time I go in there, it's true, right? So how the heck am I getting falses, right, if I'm not going in there? Am I somehow going in here for false, or is it going here for false, or is it going down here for false? Is it getting here somehow, where it's not colliding with anything? Whoa, that's a possibility, right? Because remember, we have a case where, I'm just going to erase all this stuff, just to make it clear. We have a case where I'm looping through each object in objects, right? Each of the objects in my collection. which again is either an obstacle or a target. There's only 3 obstacles and 1 target, but I have many agents, many path nodes and agents. That's what I'm sending in here. I'm checking for each agent. I'm checking that this is working. That's why this is a weird thing, because what's happening is I'm doing a line of sight check many times. If I go to my placing .cpp, I'm going through here and my check agent line of sight. And what I'm saying is when I check my path node line of sight, I'm checking agent line of sight for each path node. So that is my agent. My path nodes are my agent when I go in here. So this is when I'm checking my path nodes. Okay. I'm getting the target direction and the normalized direction and all that kind of stuff because my path nodes have they don't need a direction, right? Or do they? Look what's happening here. Here it is, right? Where I'm saying my target direction is my target position. Here's my target position, right? And where my path node get transform position, right, minus this is the direction I'm looking in. And my normalized direction is my util normalized, my target direction. So I'm actually calculating a direction anyway, right? And my path node set current direction. I'm looking at the normalized direction that I'm looking at. So I'm looking at a particular direction. Do I need to do this anymore? Do I need to do this anymore? Do I care to do this anymore? And I'll leave you with this before we move on to the next little thing. Think about this. What's happening here? So for each path node I'm checking, I'm going to check agent line of sight. Let's move in there. So it's always true because of the path node. Yeah, let's go here. So I'm going into the path node, right? It's a path node. I'm looking at the display object that I'm checking. Path node and target. Path node and target. That's what I'm checking. Path node and target. Okay, so for every path node, I'm checking with the target to make sure that I have line of sight. Line of sight starts at false. Agent has line of sight. We reset it to false. Every single frame. What we're doing, we pass through. I'm getting my distances and all that stuff, and I'm passing through I do a for each object in the display list. For each obstacle, right? For each obstacle or target. Well, this is for each obstacle because we're not including the target until we come down here. This is where we include the target in the list. Once I load up all the obstacles that are in the scene for each node, that's what's happening. Then what I'm doing is I'm doing a line of sight check. I'm doing this repetitively. For each node, I'm going through and doing a line of sight check for each node. So I go through, do a line of sight check, pass in the agent, which in this case is the node. The agent target, which is the get transform position, agent get current direction, we already have this, and the get line of sight distance, right? So the distance, which is in our case really long for each of the agents, it's like 1,000, remember? We set that up. Then we pass in the agent target in there. So agent is a path node for line of sight check. Agent target is this. We have that information, right? And why? Because we have this get current direction. So we pass it inside here. Now we go back to the line of sight check inside of the CPP. I know it's dizzying. Now we're in here and our line of sight check is the agent, which is the path node. Okay, path node. Endpoint we have an endpoint. That is, guess what that is? That is the direction that we're looking, right? Each path node actually has a direction it's looking. That's the endpoint. But even though we have an endpoint for the path node, for each object and objects, right, we're going to loop through each of the objects in the display list, which means for every obstacle or target, we're going to loop through, and we're setting up some stuff. Rec start, which is my object get transform position. That's the rectangle of the target object, whatever that object is, whether it's an obstacle or a target. That's what that is. Width and height, we've got those informations. And the offset, which we need, okay? The offset, basically what it does is it makes sure that we march back from the center because we want to be able to start with a target. The rect start is the top left corner, not the middle. All right. Otherwise, it would start from the middle to the bottom right and it would be off. That's why we need this offset. So this is cool. And then we start and say, what about object get type? We check the object type first. Now, nothing that says we can't check the agent type first, but we're checking the object type first. Okay. If it's an obstacle, return false. No matter what. If it's an obstacle, we always return false. We do a line rect check. If it's an obstacle, we're checking. Okay, cool. That's the obstacle we're checking, and we're going to return false. If it's the target we're checking, well, it depends now on the agent type. If it's the target, and I want to do a check to see if I've got a connection with the target, right, then I'm going to check my agent or my path node. So I'm going through this with you. Line rect check if it's an agent, so if it's a ship. Line rect edge check if it's a path node, which I don't pass in. Even though I have a direction for my path node, I don't pass it in. My direction is here, endpoint. But I'm not passing it in, even though I have a direction. I have a start point. I calculated my direction here, right? I calculated my direction here, but I don't need it. I don't need this thing. Why? Because I'm ignoring it if it's a path node. Okay, so even though I have it, I don't need it. And in my collision manager, I go through and you do a line rect edge check. And a lot of times it returns true. So where the heck does it return false? Where does it return false? Here. And here. Okay, so nothing was hit. That's an error, guys. Right? Nothing was hit. Let's see if we get any of those, because that's going to return false, false, false every single time in our line of sight. And that might be an issue, right? All right. Well, nothing there, right? We never even got there. Never got there. So nothing was hit. That part there was never done. We never did not collide with something. Okay? Otherwise, we would have seen it. So this is not the issue. So Miguel says always true because of the path node. Yeah, but if it's always true because of the path node, then if it's a path node, then we should actually have a true, not a false, for every object we're checking. For the target, when we're checking a target, where the target is loaded into the list, into the contact list for each path node, it should be true if this is true. The only way that this would be false is if each of the points, right, each of the edges around the target, right, each of the edges around the target coming from a path node is false. It's blocked by something. Okay. Can we render line of sight lines to it if we check the right point? Yes, we can, but the problem is we can't do it from Collision Manager, right? Because Collision Manager, if I was actually to draw a line from our calculation, from our start point to our end point somehow, even if I did it here with a start and end, if I tried that, if I said something like util, draw a line, oops, draw a line. I'm going to leave this for you after this, guys. We have to try and move on because I'm running out of time. Start point and end point. If I did this, let's see, util draw line. Why wouldn't it work here? Run it. Why wouldn't it work there? Why am I not getting lines everywhere in here? Because this is being rendered outside of my rendering loop, right? Remember what's happening in my game loop that's in my render, where I render present and render clear. I have to wrap that around the line. And anytime I do that, right? We can create a getter to display it. Yes, we can. We do a lot of stuff, but that is for you. I'm just giving you some sense of, hey, something is wrong. It's not quite perfect. This is something that I'm pointing to you guys to tell you it's not quite perfect for this stuff. it's going to be off a little bit, right? You need to fix it. How do you fix it? That's what I'm pointing out for you. Okay, last thing before we go. So we didn't quite do this. Not as well, but we did better. All right, we did this. We fixed the bug because that was the bug where we sometimes have line of sight that thing. We did a rect edge check. We did improve our line of sight check because we know what it does now a lot more than before. We didn't create this find closest path node function, which I'm going to do now. All right, so then we'll be done. So my placing.h, I'm going to go, and this is for your lab 10, right? I'm going to add in a little function. It's going to be a path node pointer. It's going to return a path node pointer, and it's going to say be m_find closest path node. All right, I'm going to pass in the agent, and it's going to be called the subject. We can actually also call it the agent. Doesn't matter. All right, but that's the subject, right? So we're going to generate implementation. There it is. Okay. So what will this do? Well, we're going to do like a minim function, right? We're going to say that auto min, that's equal to infinity, right? And we're going to start off a path node pointer where we're going to say that the closest path node, right, is equal to null pointer. So we're going to say we don't have a closest path node, whatever that closest path node is, right? And then for each, we're going to do a for each in the grid, for each node in the grid, so auto, so path node. For every path node in the grid, then I want to do a I'm going to say that the distance is my util distance between my agent get transform dot position and my path node get transform dot position. Okay, so that's going to be the distance, right? For each path node, what's the closest path node? Okay, and if my distance is less than min, this is just like doing a min function, like I said, then min is equal to the distance, right? Otherwise, and then the closest path node is equal to the path node. So this is going to find the closest path node to us, right, for each of the objects, right? And then what we're going to do here at the bottom is we're going to return the closest path node. Okay, so this is going to be our little function. And I'm going to put this up on GitHub. And that's going to help you with finding the closest path node that does not have line of sight, okay? So again, I'm going here, and I'm going to go home, and I'm going to go to changes, and let's say, yes, save, added, find closest path node function, right? Home, sync, and push. So that's going to push everything up to GitHub. So you have this little function now. How do you use this function? And then we're done for the day. I know we're running right out of time. I'm going to take it right up to this point right here into the update function, right? That's where you use it, right? And what you do with it is you say something that looks like this. We have our check path node line of sight. We do a check agent line of sight. You can do that too. But we can also do something that looks like this. I want to find the closest node. Let's say the closest node is equal to m_find closest path node to the ship. That's how you do it. So what is the closest path node to the ship? This closest path node, I want to say that the I want to check to see if the ship is in a path node that has line of sight or not, right? So just to make clear, let's just for demonstration purposes only, I'm just going to comment this out, and just to show you how this might work, right? You need to do both the ship's direction plus the line of sight or the path node. But just to show you, I could do something that looks like this. I can say something like m_p ship. I could say that set has line of sight to the closest path node, closest node, has line of sight, right? I want to go to the closest node, whatever that closest node is, right? I want to know what the closest node is to my ship, what is the closest node that I have, and what is the line of sight status. It's going to change the little line from red to green. That's what it's going to do. It's not exactly what we want, but it's a step forward. Again, I can't give you everything, right? Because then I'm doing your thing for you. And there is a problem, right? But I want to talk about this a little bit. So let's run this thing and see what happens. So here is my ship. It's red because I'm in a red node. Let's move it to a green node down here. It should move this thing from red to green. Let's do that. So if I go, by the way, this doesn't matter anymore, all right, because I've disabled the ship, right? So it doesn't matter how I'm pointing. If I move my ship down into an area that's green, then the pointer becomes green. So the ship takes on the line of sight properties of these points here. And my friends, we don't care what their ship is pointing. Remember, in the game, game I'm making you make, which is that little assignment for outline, it doesn't tell you that you must have direction. Okay, it doesn't say that. It says that there's nothing in here that says that the enemy has direction. It just says has line of sight. There is no direction for the enemy, nowhere in here, right? But it needs to move to a place where when I move behind cover, it's going to find the closest node, I've just done that for you, to the player that does not have line of sight. Okay, closest node I found, closest node without line of sight, well, that's going to be the new target, isn't it? A target for this thing to move towards, right? And what I can do is I can detect if a node has line of sight or not. Again, if I move this back, let's run this again. If I move this, again, down, so this is, let's say I move it down here, you can see that it turns green when I'm in the green area, right? And when I move it back up, it turns red again when I'm in the red area. Again, it's kind of hard to see, but you can see that as soon as I go down here, I'm in the green area because I'm next to the closest node to me is a green node, so therefore I become green. Okay, don't care which way I'm pointing because that's not the exercise. But I can do better. I can do better than this. I can do both. This, it has to, for me to have line of sight, my ship, I can do it the other way. I can say my closest node has to have line of sight, and I can also do this check right here, which kind of overkill, but you could do this, right? Because now that check doesn't just return void, it returns a Boolean, true or false. Now it's not going to work that way anymore, right? So if I run it one more time, you're going to see that it's red, but even if I move this down in here now, it still stays red unless I'm pointing in the right direction and I'm in the right distance. So again, I'm moving the ship to the right and up, right, where I have the right, that's not quite right, but there's probably a bounding box that I'm hitting, where I'm hitting the, kind of the bounding area, which is good, right? So that is, sorry, it's kind of hard to see with my issues. There we go. So it makes sense. So that works okay. So if both things, if I'm in a green node and this is triggering, then I have line of sight. So I'm doing the positive. What you're looking for is the negative, something that I can get the closest node that does not have line of sight, right? Check to see if it does not have line of sight. That is the new target for my ship. Move there. Okay, it's pretty simple. All right, questions around this? What do you show for your lab, right? What I'm looking for is, I want you to show some code. So one of the things for this one is we've done some rejigging. We did this, right? So take a look at the line of sight check. Show me some of this code, right? Again, no videos, just screenshots if you could. I know it's kind of hard to show this, but once you show this, then I can see clearly that this is happening. Also in the collision manager, we have this new function that we made, right? Which is this one, line rect edge check. Once you show me line rect edge check, I know that you built what I've asked you to build, right? Which is, it should be better, but somehow it's not triggering. And here's a hint as a challenge for you guys, right? Why this is not triggering. And I want you guys to see if you can figure it out, because this is a challenge. It's this piece. It's this piece, right? Wait, not this one. It is this piece right here. False. And this piece here, right? If it's my target, right, then I do a switch case. I do a switch case on my target. And I'm returning something every time, except for this case, which I never get to. So in this case, if I ever get here, then I'm always returning true. If it's an agent or a path node, right? This is the only time. If I leave this target area here for my target, then there's a chance that these two things, one of these two things can fail, and then I won't return true. I'll come down here and return false. But studies have shown that every time we come down to this point, we never get here. We never get here. We're always returning either this or returning this. We never come down to this, which means that up here is what's happening. I'm doing this every time. Okay, and that's why my obstacles are red and not, or sorry, red, but they should be green. Okay, it's not sensitive enough. I'm not doing the right thing here, right? So let's see if you can rejig it. I'll leave that to your thing. I'm not going to mark you against it if you try. I want you to try and fix it. I want you to see this is the last lab, right? So I know I've given you a bunch of stuff. Try and make it so that you can, as a challenge, fix the problem. Make it so that the problem that we're having, if you can, that'd be awesome for some of you. If you can just try so that this node here and this node here, right? Well, this node is probably doesn't have line of sight, but this node and this node, in this case, this is a case where these two nodes should have line of sight, because you can draw a line, a sight line, from here to the edge and from here to the edge, and especially from down over here, from this node and maybe even from this node. Okay, these nodes here on the edge nodes, some of them should have line of sight. This one, this one, this one, this one, these ones, probably this one here. Okay, and maybe even this one over here. You draw a line. Okay, because line from here, not to the middle, to the back. Okay, so take a look at that and see what the issue is. All right. Maybe the obstacles are bigger. Yes, there's lots of stuff you can look at to check this out. You can draw the obstacles. You can calculate. You can do some troubleshooting. This is a bit of a needle in a haystack that I want you to figure out. And you're close. You're very close with what I've given you. You just got to figure out one of the problems. And if I would love to see your solution. So again, please, report on this one. Okay. Questions for you guys. We did this part. Questions for you guys before we go. All right, guys, thank you so much. That's the last lab if you do that. And I know some of you really worked hard on your homework. I think it's great that you guys are trying it out. And again, fooling around with it. I think fooling around and like really playing with the code is going to make you a better coder. It's going to make you a better debugger, right? And slowly, you're going to get there, right? So please keep trying and trying to improve what you're doing, because you're going to need these coding chops as you move through our program. Okay, so let's see how you do it. I'm looking forward to seeing your solution for assignment 4. And that's it for me. I'm going to stop recording now, and I'll see you guys next week. All right, take care, guys. Thank you so much. And